question 230, which is kth smallest element in a BST. Let's read the question. So we're given a root of a binary search tree and integer k. We have to return the kth smallest value of all the values of the nodes in this tree, which is basically the same as saying the kth value in the tree. Um, so let's first understand what is a kth smallest element, kth node smallest, what is a balanced search tree or balanced binary tree? So let's draw the nodes first. I'll draw a node here, I'll draw a node here, I'll draw a node here, and I'll draw a node here. And I'll take a line which is here. So I'll draw this arrow here, and I'll draw this arrow here, and there is no here. There is no node left to it, as we can see in the example. There is no node left of the first node. So I'll just take a numbers and I'll write them. So this node has a value of 1. This node has a value of a my handwriting is a bit sloppy. 3, and this value node has a value of 4, and this node has a value of t. So what can you see? Well, we can see that this node has value of 3, and this node has value of 4, and this node has a value of 1. So we can see that for every node, the all the nodes to the left of it has value less than the current node's value, and all the nodes to the right of it, all the nodes to the right of this node has value greater than the node. Okay, so now we understand what is what is a BST, what is a BST or balanced binary tree. This is what is a balanced binary tree or balanced search tree. That's very many application of it. Now we have to calculate get the kth smallest value or the kth element, kth value in this node. Since all the elements to the left of the node are less than that, and all the values to the right of the node are greater than that. So we could go. So we will start from how to traverse this such that we have the kth element, kth value, kth smallest value. There are three to four. There are three main ways to traverse a binary tree. One is pre-order, another one is post-order, another one is in order. Let's look at pre-order first. What do we do in? Let's look at pre-order first. What do we do in pre-order? What do we do? We start with the root node, and we first start with the root node, and we first do some action on that node. Let's take a 3. So we print the value of the node and we go left of that node. We go left of that. Uh, we go left of that. We go left of that node, which is this side, and then we print that node and we go further left of that node. We see there is no. We see there is no node here. So we come back and we go right side of this node and we go further left. So before going further to this, I'll print this node, which is 2, and I'll go to the right of this node. I'll go to the right of this node. I'll go right of this node. Oh, there is no node. I'll come back and I come back from here and I go left of this node. Before going the right, left or right of this node, I'll print this node, right? So I will print this node. I'll print this node and I'll go to the left. So sorry. I'll go left and I come back, there's no node, and I go to right, come back, there is no node, and I come back here and I finish traversing the entire binary tree. What do we have in here? So we printed 3, 1, 2, 4. Is 3 the first element of this binary tree? Is 3 the first element of the binary tree? No. So let's look at, so this won't work. So let's look at another order and traversing, which is post order. Let's look at post order. What do we do post order? We first traverse all the left elements of the node and the right element, then we print it. So in this example, what we will do is start with the 3, and we go to the left. Oh, there is no node. We come back and we go to right of this node, left of this node, there is no node, come back, then we go right of this node, left of this node, come back. So this print 2, then I 1, then I come back, I print 1, then I come back, then I go to the right of this node, left, right, again, I'll print 4 and 3. This is what post order says. So basically go left and right of a node, then print the value. So this even does now. But in order, so this won't work. So this won't work. There is in-order traversal. So what does in-order traversal do? Well, in-order travel what in-order travel does is first we go to the left. We go to the left of a node, and so let's say we go from left of this node. I come back. There is none. First, I print this node, which is 1. Then I go right of this node. Then I go right of this node. See, I go right of this node, and again, I go to the left of this node, I come back. Oh, I print this node. Before going to the right of a node, I print this node. So I print this node, which is 2, and I come back, and I come back. Before going to the right of this node, I print 3 and I go to the right, left, right, left. Before going to the right of the node, I print 4, and again go right, come back, and I've traversed the entire array. So what we can see is in order, it traverses such a way that we traverse all the left of the node first, then we print to the node, and then we traverse the right of the node and print all the value. So does this represent the binary search tree or balanced binary tree? It's very similar to the property. It's just exactly used as a binary search tree. So what we can do is now you can see what's the logic of it. So I'll just so we can just use a so now you understand we can just use an in-order traversal to traverse the entire binary tree and return the k smallest element. So we'll just take a array and we go left and we go left, left, then I come back. Oh, it's the first node. So I'll take the node and I go to the right node. I go to left. Oh, we know traversed all the left of this node. So I'll print this and I go to the right and we come back, and before going to the right of this node I'll print 3 and I'll go right, come back, left, and come back. The fourth node I print 4, I go to the right of it. Oh, so in this array, so we could take a result of array. Let's call this result. Sorry for my sloppy handwriting. Result, and 1 2 3 4, and we could just say k minus 1 result of, so we could just say result of k minus 1 is our answer, is our, we could just return it, right? But this is sort of uh, this takes O of n space, considering this the time complexity will be O of n and the space complexity will be extra of O of n space because we have another array that takes all the elements into this array. So what we can do to optimize this solution? Well, it's pretty easy. Instead of keeping a entire array, what we have to keep is just a counter of it. Let's say we are supposed to receive the third smallest element. So let's say that k is 8, right? K is 8. So what do we do? Case 3, we were supposed to do the third smallest element. So what do we do? So we could just create a counter of 3, supposedly a count of 3, and we could start traversing, right? So we could just take traversing. We go left of it element and left of element. When I come back, I see the first node. The first node First node. So how many nodes have I traversed so far? Well, I've traversed 3. I've traversed none of the nodes since the count is 3. So since I've traversed the first node, I could reduce this count from, so 3 minus 1. So 3 minus, I'll just take a, so 3, I'll take an empty space here. I'll just erase it. Give me the rubber, bro. I'll just erase this, all of them. So I'll just take 3 minus 1 is equal to 2. Okay, so then I go to, is this equal to 2? So have we traversed up to kth element? Nope, it's still 2. So I go to the left and then again. So, so I go to the left, again go left, I come back, and I get another node that I'm supposed to print. But before printing, what I'll do is I'll minus from the counter, which is 2 minus 1, 1. I have I traversed the k elements up to k elements? Nope. I still have one more element to traverse before I can say I found the kth smallest element. So I go to the right. So I go to the right. There's no node. I come back. I come back. I've traversed all the left hand nodes. I come back and I've found another node. Right before printing that node, what I'll do is what I'll do is if the counter is now 1, I'll reduce 1 from it. Oh, it's 0 now. So I've traversed all the elements. I've traversed up to k elements. So I can just return this value, right? 3. Oh, nice. Good. That is it. That's the over. So we just use, so this problem can be summed up as using in order traversal to traverse up to kth element and returning. Okay, so the time complexity will be O of n, and space complexity will be O of n if you use a recursive solution, which is what we will be using, and O of n if you use O of n. Space complexity is O of n, which is still better than O of n if you use the counter approach, or O of m plus 1, m n plus n, O of n plus of n plus n if you use a if you use a uh, array approach, right? Array approach, right? So let's jump back to the code now. Okay, we are here at the code, and so I'll just create a new file. Let's call it binary tree. So binary tree k smallest element in a BST2. Okay, so let's start writing code. So we'll take a main function first, which is, let's call this k smallest, which will take the root binary root node and an n and a k. What I'll do is I'll write a recursive approach if in order approach, and I'll take the current node here and the k, which is a counter. So counter, we have to initialize a counter. This will serve as our counter. So if there is no node, I'll just return none, right? Right. And I have to start traverse from, so if there is a node, I have to traverse the left of that node. So I'll say in order node dot left and pass, and sorry, I don't have to take k here since it's a global counter. I'll traverse the in order left, and if I'll take left is equal to this. So if left is not none, so if we have found the kth smallest in the left node of a tree, I can just return left, right? If not, if I've not found it, so I've come to another node in our way of achieving kth value. So I say I'll decrement from our counter that we have encountered another element in our pursuit of traversing up to kth element. And if I'll check if the counter has reached 0, I'll just return the node's value, right? If not, I'll traverse the right of row. So whatever this will return, this could return none, or this could return the right of an element. Whatever it is, we have to return them, right? So I'll just call this in order, and I'll start with the root. Okay. So if I just take this code and if I paste it here, I should have the solution. In order, I just have to return this. Can't forget returning the answer. Return node, I'll just return node value. I'll just check once left. If left is not none, sorry. If the left node is not none, so if we have found an answer, it is left, I'll just return left. If we've not found, I'll decrement from the counter, and I'll say k is if the counter has reached 0, meaning we have reached up to k. If we have traversed up to kth elements, I'll just return node value, else return in order, right? If I just run it, I should have the answer, and if I submit it, boom, let's go. We did this, boys. And yeah, that is it for today.